Okay, move ahead to the next pattern. Answer a few questions. Question is, where the CEO object is created in the company class, right? So it is not created. I don't get entire implementation, right? We need to first actually create a CEO class that implements the employee. And in our case, CEO would be a composite object, a composite class which will be able to include atomic objects inside it. And then you will be able to create the object of the CEO class in the company class. Right? The object implementation I have not shown. I think you missed the part where I told that I am just creating a part of that tree. A very small portion of the tree is what we created here. The left-hand side, where a general manager who had a manager and clerk inside him, and the manager further had 2 clerks, right? There was one more question. If we had a new interface in the manager class, like show manager details, there will not be called as a composite pattern. So you have written that because then we will not be able to access all the atomic as well as the composite objects using same interface, right? Can you please show us the pseudo code for this example? So you want me to show how one would write the pseudo code in case you are not familiar with Java, right? So I can do that. So instead of adding it right here, what I'll do is that I'll add additional slides where the pseudocode be written, and you could make out is you will be able to understand that how you would proceed by to write the pseudocode, right? We need to write pseudocode for all the classes, so that would be mentioned. I mentioned earlier also it is highly unlikely that you are asked to write the code, but in case you are asked to write the code, you would be expected to write pseudocode. But if you are familiar with Java, please go ahead and write the code Java. Right? It's either pseudocode or code in Java. Right? In C++ also, you can write it, right? But implement with add a lot of comments with it, so that the evaluator is able to understand what you are trying to do. Book we need to purchase for the comprehensive examination. So there are 2 textbooks that there. T1 is your by Craig Larman, which is mostly focused towards modeling, and it does cover the design patterns as well. Your T2 is totally on design patterns. So these 2 books are the ones that you need. In case you want to go for more books, that is your choice. So there are people who come with only 2 books, and there are people who come with bags of books to you, right? Get to the next pattern. So we have patterns still to cover, right? So next is your behavioral design pattern. So take up 2 patterns today from this behavioral design pattern category. Behavioral design patterns to help us identify communication patterns between objects and release with the help of patterns. So these behavioral design patterns really help to solve issues related with communication between objects, right? These patterns help to increase flexibility in communication between the objects. And some example of behavioral design patterns: iterator, strategy, observer, command, interpreter, template, etc. So today we are going to take up first the iterator pattern, and the next would be the observer pattern. The iterator pattern right away. Underlying structure, right? Aggregate object. An aggregate object is an object that contains other objects for the purpose of grouping those objects in a unit. One aggregate object. And for example, is an aggregate object. A list, for example, is an aggregate object. A table is an aggregate object, right? A section is an aggregate object, right? Object that aggregates within itself objects of same kind, right, is called an aggregated object. And what iterator pattern does? The iterator pattern aims to provide a way to access aggregate objects sequentially, right? It's important that it provides a way to access these objects sequentially with exposing their underlying structure. It allows for different kind of traversal methods to avoid encapsulation by data access to iterator only, right? So the key idea that this iterator pattern aims to implement is that the of an aggregate object is moved outside the aggregate object and moved into the iterator object. This helps prevent the concept of encapsulation, right? So my aggregate object, which aggregates various objects, which is a data structure kind of an object, which includes within itself the other objects, should not be troubled to wide traversal processes as well, right? The aggregate object is only responsible for aggregating and storing those objects within itself. The detailed part of the traversing through that aggregate object need to be implemented by another object. And another object is the iterator object, which takes care of the traversal part so that it increases the iteration of the aggregate object. It does only store the aggregate object and does not take care of the iterator part. Right? The iteration or the traversal part of that aggregate object is done by a separate object. And it will be more clear as we go through implementation. Right? The structure and iterator pattern has. So there are an aggregate interface, right? The important method to note in the aggregate interface is the create iterator. Okay, aggregate interface implements a method, provides a method which has to be implemented by every concrete aggregator. A concrete aggregator is a class which implements the aggregate interface, right? And it should provide implementation for the method create iterator, which turns an object of type iterator. Right? What is iterator? Iterator is another interface, right, which provides traversal methods. Right? What are these methods? Say, for example, has next and next. Right? So the has next is a method which helps you to find out whether there are more objects in the aggregate and is return you the next object. Right? So implementation of the of these two methods that are there in this interface. Implementation is provided by the concrete iterator, which actually implements the iterator interface, which is has next method and next method that returns the object, right? So these are the four participants that are there in this iterator pattern. So here's these participants. So there is an iterator, the interface for accessing and processing the elements. You have a concrete iterator, which links the iterator interface and helps you to keep track of the current position in the traverse, right? For aggregate interface, which defines an interface for creating the iterator object, right? It defines an interface creating an iterator object, right? So this we saw just now that my aggregate interface defines a method for creating the iterator object, right? And finally, I have a concrete aggregate which implements the aggregate interface and runs of the concrete iterator. That is what these are the four major participants in the iterator pattern. Let's have a look at one of the example, and then we see the implementation of this particular example using the iterator pattern. Okay, I have a aggregate interface. The abstract list in this case is an aggregate, right? The aggregates are two. There are two concrete aggregates, list and skip list. These list as well as skip list, they implement the abstract list aggregate interface, right? If you see here, my abstract list aggregate interface has the most important method, which is create iterator. Additionally, it has more methods, count, find, and remove. Right? This concrete aggregator, which implement the abstract list, provides implementation for all the methods which are listed by the aggregate. The iterator interface has four methods. First, next, is done, and the current time. Right? Number two, iterators, complete iterators which are implemented, list iterator and skip list iterator. Right? So when I will invoke a list object, I need a list iterator, and when I need to a skip list, I need a skip list iterator. Right? The implementation of the same, and then we'll be able to understand it in a much better manner. Object, right? A skip list object. Each list, right, for each of them is it aggregator. It implements the aggregate interface. Then assume that objects are added into this list as well as skip list. Right? I want to iterate it. How will I iterate it? I will obtain an iterator. Right? List iterator, I will invoke, I say list dot create iterator. Right? It will return an object of which actually iterator. Right now, okay. See, when I the skip list, I skip list iterate. Right here, I will invoke a skip list dot create iterator. This will return an object list iterator implements iterator. Right? Given the implementation that, but it's obvious that it creates a new object of skip list iterator and returns that. Right? Then use these iterators, I will now traverse the list. Okay, so these iterators provide me with like iter.first what is done, right? So there are more objects in it. This returns the first object. This one returns a boolean, which tells me whether it is with more objects in the list or not. This one actually returns the current item and takes a pointer to the next item. Right? Use this list iterator, you are able to traverse the list. Using the skip list iterator, you will be able to traverse the skip list. Right? So the skip list iterator, right? What is the difference between these two iterators? Right? We just explain that. So suppose my list iterator here's the list 1 by 1, and list iterator here's the list by skipping one element. Right? So you iterate through 1, 3, 5, 7, so on. Right? So if list iterator, the implementation would be such whenever you would say iterator.next, it will learn elements by skipping the elements. And return 1, then return 3, then 5, then 7. Right? So that means you are able to traverse list based on a particular kind of traversal method, which being governed by its corresponding iterator. Because skip list iterator is designed in that manner, you will be able to access the elements of the skip list the way you want. Right? This you are trying to move traversal aspect of the target object into a different iterator object, so that you are able to iterate through it, traverse that object the way you desire. Okay. Example of this iterator pattern already exists in Java. Right? Java provides built support for the iterator pattern using the enumeration interface. Right? Who are familiar with using Java would be able to understand this in a much better manner. So when you have to iterate through vector or a hash table, right, that was supporting JDK 1 in 1, the vector and hash table, which were the two aggregate classes. Right? When you have to iterate through these two aggregate classes, you obtain an enumeration out of it. So that enumeration is what you use to iterate over that aggregate object. And the enumeration has, I think, two methods: next and next. Right? This next tells you whether there are more elements in that particular aggregate, and next returns you the next object. Right? Moreover, in JDK 1.2, a new collection package has been introduced with addition of more classes, which include sets, lists, maps, and all of them can be iterated using the iterator interface. I hope this is clear. Iterator pattern, you can go through the implementation, small implementation example I have given here, and just try and implement this. The parts, right? So if you implement the missing parts, you will be able to understand actually what is happening, right? So this particular method, iterator list or create iterator, it creates an object of the list iterator, right? And that list iterator has to implement all the methods which are there in the iterator interface, which get is more first, next is done, right? Similarly, my skip list is supposed to implement that particular those methods. The skip list has to be traversed by skipping one object another, right? And once you are able to implement all these data, then you can use them to traverse the list. I think for the iterator pattern, I'll take up a few questions and then we'll move to the last pattern for the day, which is the observer pattern. The question is, pseudo code should also be of Java code. I repeat, preferably yes. But here with Java, pseudo code is what is expected to be written in English, right? You can say invoke creator iterator method on list object iterator, right? So English language, right? So you can refer to any kind of any data structure kind of a book where you would definitely find a lot of pseudo codes that are written, right? Pseudo codes do not specifically use the syntax that is there to a particular language, but they are written more in English, right? A difficult thing to do, it says that if possible, please provide the pseudo code for all these patterns for people who don't know Java, right? So that's really difficult for me to do. I like people to opt to do. So if just convert at least few of them into pseudo code and mail them to me, I will put them on the portal and we can do it. Okay, question coming for the second time, how we can access skipped elements in a skipped list implementation, right? That is that would be elements which you intentionally want to skip. You do not want to access the elements that you have already skipped, right? Implementation is that kind that you want to only access the odd number elements or the even number elements. So you need not bother that you have missed out some elements, right? It is the requirement is such that you want only the even number elements or the odd number elements. Okay, so in comprehensive exam perspective, is it required to go through the patterns which are not covered in the contact session? So you please keep your course handout as reference point for the along with the recorded content. So that content is in line with the course handout. So that form the just for your comprehensive examination. So what is covered there is what is your part of the course. I covered most of the questions. The majority of the questions move around the concept that how we would be able to pseudo code for these. So I will try and put in a few of the pseudo codes as far as possible so that you understand how you would have to write the pseudo code. Okay, there's a request to take up a case study and explain how the patterns can be applied to that particular case study. That is there in my mind. I'll try and arrange a tutorial session for the same to take a study and see how explain how the various design patterns can be put into that case study, right? Okay, and let's see, last design for the day is the observer pattern. Observer pattern is also a behavioral pattern. A one-to-many dependency between objects. So when object changes state, all dependents are notified and updated automatically. Many dependency observable, right? And to call the subject, and many observers who attach themselves to the subject. The a concept which is called state. The state of the subject changes. Objects need to be notified. Right? We are behind the observer pattern. There is a one-to-many dependency relationship. One is in which subject or the observable are observers. They attach themselves to the subject or observable. Yes, some the state. When a state of the observer changes, the observers which are attached to the subject have to be notified so that they can be updated automatically. Encapsulates engine component, which is the subject abstraction. So my subject is actually the engine and a variable components in the observer hierarchy. Right? What are the participants and how the work flows? So it's an object which is called the keeper of the data model or the business logic, and this main object is the subject or the observable, right? So my subject or observable is something you observe, right? This is an engine and defined as the keeper of the data model. Right? Defined in this way that the data model is stored with a subject. When a change, action is sent to the observers, which actually right? The observers actually provide the UIs or views for display of the data model. Right? As soon as the data model changes, the view part is also supposed to change. Right? So observable or the subject is the key of the data model. It does all functionality to be coupled and distinct observer object. Right? An observer object does not know what are the other observers which are attached to the subject. Right? But the subject is aware as to which are all the observers that are attached to me. Observers register themselves the subject as they are created. The subject it broadcasts to the registered observers that changed, and each observer queries the subject for the state change and display the change accordingly. Right? Very clearly, It is also called the publisher-subscriber model, right? So, and with subscribe attach themselves to the publisher, right? Publishes its states, and the subscriber get to know that there's a change in the state, right? Again, the observer pattern again. So there is a subject, which is the keeper of the data model. It is observable. It's data model. There are a number of observers who attach themselves to the subject or observable. The state of the subject changes. It notifies the observers about the state change. He queries the subject for the change in the state and plays the change state accordingly. Right? And in a much better manner as we move ahead. So the structure of the observer pattern, subject, right? It has three methods: attach, observer, detach, observer, and notify. Right? Three methods are important. Concrete subject that is there must implement these methods which are there in the subject interface, right? Then there is an observer interface. The interface has an update method. The update method, the observer implements the observer and writes implementation for the update method, right? Ideally, there are four participants: the subject, which implements the subject interface, the observer interface, and the complete observer interface. The complete observer class, which implements the observer interface. Right? Let's implementation of the same. Okay. Our keeper and view the other names for the observable and the observer respectively. Yes, you can take it, but ideally it is not a standard name. Okay, but it is like maintains the model. The observable or the subject maintains the model, and the observers are usually used to display the changed state. So that is why they say the view there. Okay. Classes, why are you calling it as an interface? Explain again, subject and observer are interfaces. They are not classes. Subject and concrete observer are classes. Concrete subject implements the subject interface. Concrete observer implements the observer interface. Right? Clarifies which participants are classes and which participants are interfaces. Right? Okay. Let's go ahead. So the participant, the subject, which is also known as the observable. Observable is an object which notifies the observers about the change in its state. A number of observer objects may observe a subject or observable. It also provides an interface for attaching and detaching observer objects. Right? This is what we saw. My observable or subject must have an attach method, must have a notify method. Okay. The next participant is the observer interface. It defines an updating interface for objects that will be notified of changes in a subject. So this has an update method. Right? The concrete subject implements the state interface state of interest of concrete observers, right? Whatever is the state which the observers are monitoring is stored in my concrete subject. Additionally, send a notification to its observer when its state changes. So it has a implementation for the other methods that are there, right? So this is my concrete subject. It's a state, and additionally it will have state and get state methods, the subject state, and it will provide implementation for the attach, detach, and the notify method, right? Participant in the is the concrete observer. It maintains a reference to the concrete subject object, right? My concrete observer needs to maintain a reference to the concrete subject object. This is important, otherwise it will not be able to get the state from the concrete subject, right? So you need to maintain a reference of the concrete subject, stay consistent within the subject state. So it even maintains a reference to the reference where it stores the current state of the subject, so that it subject for state and then displays that state. It is the observer interface to keep its state consistent with the subject state, right? So this is what we saw. The complete observer is the update is which is provided by the observer, right? Important participants in the observer pattern. Let's move to the implementation. Happily, the observer pattern implementation is provided by the inbuilt in Java. So Java provides observable and observer classes as inbuilt support for the observer pattern. This is there in the util package. So there is java.util.Observable class, which is the subject class, right? This is a subject class. One can implement this particular and provide an interface. So one can implement this particular interface and implementation for rest of the methods. Additionally, there is java.util.Observer interface, which can also be implemented. So I show you an implementation of the same in Java. Before that, table has the method add observer, so that is required as a delete observer, right? So add and delete observers are required in the subject. So you can add a observer, delete observer, then set changed indicates that if the state of the object has changed, this method is used to indicate that this object has no longer changed, right? So once it has notified all the observers, it changes its state to a clear change, so that no more so that there does not happen that there is a repeat notification that is being sent to the observers. So once all the observers have been notified of the recent change, you clear the change so that there is no repeat notification that is sent to the observers. Methods has changed, notify observers without human, so that it iterates over all the existing observers and notify them, right? So you can go through this documentation. Then this observer has the update method. I'll quickly show you the implementation. So okay, which extends the observable. So this is, in this case, they have made it Java, they have made it as a class, not an interface, but ideally it should be an interface, otherwise you'll not be able to abstract you'll be able to extend more classes, right? But in the way that they have done it, so it extends the observable class, which is an abstract, which is a class, observable class, which parallel to the subject interface. Let's see what is this particular concrete subject doing. It has two tail objects, right? It has a name, it has a price, right? The idea is it maintains a state in terms of name and price, right? There is a change in the name or the price, which is the model of this particular class, which is the state of this particular class. The which attach themselves to this concrete object should be notified, right? That's the whole idea, right? So this is the constructor of the concrete subject, okay, and two the methods for name and price. Okay. So there is a setter method, set price. These methods are important. When a set name or set price are out, that means there is a change in the state of the subject. The state of the subject is defined in this case in terms of two that it has name and price, right? When there is a change in the name or price of the subject, the observers are to be notified. Now, these which are private attributes of this concrete subject, in them, one needs to invoke the set name or price method. That means whenever these two methods are invoked, the state of the concrete subject is right. That place where you need to invoke the notify observers method, right? And that you can see here that the attribute is changed to the incoming name value. That method invoke, right, which term that there is a change that has happened, right, and then it in the observers. The observers are notified with the new state value, right? You can see passes the name value as an argument to the notify observer method, right? Notify observer method takes a which is the system which has changed, which is the object of the system which has changed. Internally, this notify observer method loops through all the observers, right? And it will pass the name value to the observers, right? Then this method similarly it does the same thing, right? It sets the price to the incoming value, change is invoked, and then notify observers is again invoked by passing the value. Okay, questions? Just let me finish the section. That is the now to the concrete observer, right? So my name observer, which means the observer interface, is now a observer that attaches itself to the concrete observer, right? Now what observer does, it is interested in the name, in knowing the name object of the observer, right? So this is my of the name observer, and then it implements the update method of the observer. Right? What is when notify is invoked by subject, the of the subject invokes the update method of the observer. Right? The observer will change. If the of change is change, it says that the name has been changed. Without that some other change has happened to the subject. Right? Similarly, there is a price observer. Price observer implements the observer interface and has a price method attribute with it. Right? Now it also implements the update method. Now, the noted object invokes the update of this particular observer, right? Passes to it this object argument. Right? Now it scans whether it is an instance of float. If it's an instance of float, that means the price has changed, then only this price observer is interested. Other something else has changed to the subject, and then the price observer is not interested. Right? Okay. Let's participate this pattern with the client. Right? What my client does, it's an object of concrete subject. Object S of concrete subject is created with two attributes, name and price. Right? The observer object is created and a price observer object is created. My observers are attached to the subject. So it says f dot add observer. Passes to it an object of type observer. So f dot add observer, the price observer. Right? So this we see that the object, the observers are attached to the subject. Now, subject maintains a list of these observers, and whenever the observers have to be notified, it iterates through the list which it maintains. Right? The update method of each of these observers. Right? Also, all this internal implementation of add observers is on for you in the java.util.Observable class, so that you directly use it. Right? However, it's not done. If you do not want to use those two classes and the observable interface which is there in the Java, you can actually implement the observer and observable from scratch without using the inbuilt classes as well. Right? To the implementation for the add observer, the idea is that the subject maintains an array list of observers. Right? And you add observers, when you invoke add observer, you add to that array list. Whenever you have to delete, you delete from that array list, and whenever you have to notify the observer, you iterate through that array list and invoke the update method of all the observers. Right? Then dot set name. Right? When the name is set, your name observer will be notified. Right? Because in s.setName we had written changed and notify observers. Right? So say s.setPrice, the price observer will get notified. Again s.setPrice, price observer will get notified, and again the observer gets notified of the change in the state of the observable. Right? Let me just clarify. Right? Okay. This question, when there is a change in set name and set price method invoke, observers will notify whom. Right? Question came before I came to the slide. Right? So now I hope you understand that to notify, right? So you have added those observers to the subject. These are the people, these are observers who are attached to them and they need to be notified, right? When password, we get a command after password, your password is changed successfully. Is it an observer pattern? No, that is not an observer pattern. Which I don't want to take up now. I mean, that's too late for the question. To the first class, what is the difference between an interface and class? So, this one question that should have come in the first class. Please go through few books and you'll be able to find out what is the difference between an interface and a class. Okay. I think if it is clear. Change and notify methods, these are very commonly used in the graphical user interface classes which are inbuilt in Java. So when there is a change in the value of a table, right, the values which are to be listed in various rows of a table, the table UI gets notified and it updates itself. Right? These kind of places are where Java pattern mostly used, right? Data model maintained using a table model object and the UI is displayed by a separate object. So whenever table model changes, the UI is updated automatically by the notification. Question, you had set and notify methods. Where are those implemented? So those implemented in the java.util.Observable class. Right? In this case, in Java, java.util.Observable class is implemented, and any class which is a subject, instead of implementing an interface, it extends the observable class, right? And where implementation for these methods is already provided. I said for today, we'll wind up the session now, and in the next class, we'll move to the graph pattern. That is going to be the 10th lecture of this particular session of this particular course, and then we'll be left with one more session, and we have two topics left: the graph patterns and the solid design principles. So in case I'm not able to cover all this in two remaining lectures, we have another extra lecture, and then also I will try to arrange a tutorial case study versus the application of various design patterns given a case study. Right? And just to add, just to remind, in line, so I will upload the list of the submissions of phase 1 that we made. I also upload the details about quiz 2, and maybe at the maybe after Diwali is what I plan, is that I will upload the phase 2 of the quiz, of the assignment. Phase 2 of the assignment I plan to give after Diwali. Right? Can you follow the design patterns? I will do that. Okay, that would be really good. If I upload the phase 2 after Diwali, it will be too late. We have freeze on November 20. Okay, I appreciate that. So I will try to upload it before Diwali. But your phase 2 will not be as elaborate as your phase 1 was. Phase 2 is possibly be on design pattern. patterns, no UL modeling. For the same case study that you have chosen, you have to apply in pattern and explain the reasons, right? So this is broadly what I'm thinking. I play it in the phase 2 document, but there will not be much effort that would be required to be done in phase 2. And that is the reason why we divided the phases, because if it is all in one chunk, then it will risk that it will not come ever, right? So this was the plan. So thanks for attending today's lecture, and keep looking for more for the announcements there on the portal. Okay, so much. Any queries, please feel free to write mails to me. I often try to answer as many as possible.